Welcome to the Terminology Leading Practices stream of SNOMED CT Expo 2024, and thank you to B2I for sponsoring this stream. My name is Nick Egerhaus, and I'm the Global Vendor Engagement Lead and Customer Relations Executive for the Middle East, Africa, and North America at SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of the presentation, and online attendees, please use the Q&A button to type your questions to the presenter. On-site attendees, please use the microphone provided in this room. I'm now pleased to introduce Vlad, Dinu, and Shubham Agarwal from King's College London, who will be presenting Relation Concept Annotation for SNOMED CT Concepts. Vlad and Shubham, go ahead.
Yeah. Good afternoon. Thanks for having me here. So today I'm going to talk about the Relation Concept Annotation tool for SNOMED CT or RelCAT. Oh, sorry about that. There we go. So I'll walk you through the agenda. So we'll first focus on what is relation extraction, and then why do we need it? What is RelCAT? What data sets or data do we use RelCAT on? What training methods and models they produced and also applied? And then, of course, lastly, the results. Oh, sorry. I need to get used to this. Oh, no. Why are the slides appearing like this? Yeah, well, that's not the original slide, but whatever. The background is off. Anyway, so what is relation extraction? That's what it's supposed to be there. So relation extraction is an LLP task that focuses on identifying the relationships between two or more entities and mentioned text. The goal, of course, is to extract the structured information about how the entities are related from unstructured text. Of course, the process should be easy. We first focus on getting the entities. So that's a named entity recognition task, detecting the relationships between the entities, and then trying to classify the type of relationship. All right. So how do we do this? Ideally, in our world now, today's time, we should have an ML model that can reliably do this. Of course, there are a couple of challenges, and that would be handling the complex nature of documents and electronic health records, a problem which is especially predominant in the UK, at least. We're dealing also with implicit relationships, and also we need the disintegration between the entities and the relationships themselves, because these are two different tasks, and so the context might differ. So how do we do this as well? What techniques have been applied so far? We got rule-based approaches. This is super basic. It can be anything really. Regex, you could have a dictionary mapping saying, specifying the relationships and so on. But obviously that won't work so well. And then you got the machine learning ML methods, and ours include deep learning models, so BERT and other large language models. All right. So why do we need to do this? Well, first of all, because it's really useful in the medical domain. You have a lot of documents, and it will be a shame not to actually use them for this task, especially to improve patients' lives. So on the first level, we can help directly the clinicians to get a better view of a patient's condition, and we can also help researchers potentially to identify new disease trends and also discover new medical knowledge, if there's anything to discover, of course. All in all, the conclusion is that the decision-making should be improved by accurately extracting relations between entities. And a few examples here can be symptoms, diagnosis, and medications. Okay, so I'll give you here a simple example of a relationship. It can be a spatial relation. We can define that as being the physical location of an infection, of a disorder in a region of the body. For example, you have radiology reports, which can definitely, a relationship extraction could help for surgical planning and treatment. And another example here at the bottom is relationship between adverse drug effects and drugs. There's two mentions of adverse drug effects and two drugs, of course. This sentence might need a bit more context to understand than this, but yeah, for the simplicity of the example, we provided only this. All right, and now we can introduce RelCAT. Switches. Oh, there we go. Okay, so you might have heard of MedCAT, and so this is why we also named this mail for RelCAT. So RelCAT is technically a component of MedCAT, a tool which was presented, I think, a few presentations back, or on other people's presentations on today from my own team. But MedCAT essentially allows users to create, annotate, and fine-tune models using NER. So that's named entity recognition, linking, and contextualization. So RelCAT, of course, is designed specifically in mind with the relation extraction only, or rather relation classification, because the extraction is handled, the entity extraction is handled by MedCAT itself. So in MedCAT, you have two basic components, the vocabulary and the concept database. And for this, we use the SNOMED CT ontology because it enables us to extract medical terms easily and also map these terms to a specific identifier, in this case, concept identifier, so CUIs. Of course, you can build your own custom ontology dictionary with or without SNOMED. It's up to you. This tool is quite versatile, and you don't need to use SNOMED if you don't want to. We'll show this in a couple of slides in the dataset section where we actually collect concepts which have not been previously present, in the SNOMED dictionary, but they work along the current SNOMED dictionary. All right, so what does this offer us? As a standardized way this framework is a standard way to train models. It's also, we got lucky because our team is quite big, and we also created a tool to handle this, which is manual collection of annotations, which is called MedCAT Trainer. So our tool supports training datasets with output from this tool, your own input, provided that you have the entities required to train the relation extraction model, or even spatial documents, if you're familiar with using spaCy. You can use the RelCAT in two different workflows. The first is relation classification. This is where the person already has the documents and the named entities, the entities recognized. And so the only thing you're actually using it here for is to classify the type of relationship between any two entities. The other workflow is the end-to-end relation extraction, which is actually a full end-to-end pipeline, which means you input the text, and then you extract the entities and also the relationship between these entities. Of course, I need to mention this again, the NER bit is always done by MedCAT and not by RelCAT. And here we have an example of what the CDB is in a summarized way, or summarized view rather. On the right side, you got the concept IDs. This will be, in our case, SNOMED concept IDs and their actual text. And on the left side, you got the SNOMED concept, the concept types, rather, that we kind of created based on the top-level family of the SNOMED IDs themselves. Sorry, SNOMED concepts themselves. All right, so what did actually SNOMED help us achieve here? So first off, it's much easier to streamline the model development and evaluation and the training, because you can create specialized models. These would be, in the case that the task is too ambiguous, you can make specialized models to focus on only one specific class or task if you find that for some reason it's not performing well when you have a multi-class model. We also explore, or because of this, we got the ability to explore, rather, the generation of non-relationships, which will be soon presented by Shubham. Then we also have more control of what is actually annotated, because all of the tools that we made so far, including RelCAT, has pre-built methods to filter out based on concept IDs. So if you only want to target a specific family or interested in specific things, you can always just highlight that and it will automatically take care of that for you. And then, of course, it also enabled us to pursue, this is future work already, pursue relation discovery. Where here we would explore the discovery part of, or rather the research research improver part, I guess, from the first slide, from the first two slides, of how you can identify potential relationships between concepts which you've not actually considered before based on concept types or concept families, rather. And then, of course, this is also a management issue which might be present, but if you have a large team of annotators, it helps you with project scoping because you can assign, well, different person to different projects and tasks based on the cost of the annotate or the tasks, relationship tasks. All right, and here we have a few view of the MedCAT framework. So I'll first focus on the bottom side here. So assuming that we got the document data set, you have two workflows, well, two ways of proceeding by using MedCAT. If you already have the entities extracted and you set the documents, you can directly just perform training. And the training here means that you only actually use the RelCAT part. So this is to mention that, as I've said before, MedCAT itself, in MedCAT itself, RelCAT is technically just a component. It's an optional component. The NER bit is handled by the first part of MedCAT, the first pass, and afterwards the relation extraction is being done with the MetaCAT as well. Anyways, won't mention details about that here. And then you'd have the output. The other bit, if you want to perform supervised training, would be to actually have it flow the documents into MedCAT training, annotate them, and then you export these directly and perform training. And again, the output is a model from which you can then use to infer. And here we have a sample at the top with the inference document. You throw it in and you get the output, which would be the named entities. In this case, you got the first entity and the second. I'll put it there with the class as well. All right, data. So, of course, we had to get the data to prove our experience actually, sorry, our implementation actually works. As I mentioned before, use MedCAT Trainer because this is our custom built tool. It's already pretty much proven very useful for the annotation of entities in general already for most of our projects. And it allows the annotators to inspect the concepts that have been identified or linked by MedCAT visually, and also they can review them. Of course, now with the other added functionality that you can actually use it to annotate relations between two entities. Of course, there's a case where you can customize and further, well, detail your project and so on, and how to use MedCAT Trainer on it. Okay. So the important factors here is when you perform annotation, there's a couple of things to consider. There's a inter-entity distance that you need to consider for relationships. There's the contextual span, meaning what would be useful for the classification of a relationship based on the text around the considered entities. And of course, the other important bit is the concept identifier, so the filtering of related entities. And here we have a direct view of the MedCAT trainer, how it looks if you would try to annotate the entities. We're not showing the annotation of concepts here, so on the another tab over here, I can't show them both at the same time. But in this case, I say we're annotating a spatial entity. It got lytic collision in a femoral neck. It's a simple one, but yeah, good enough for me. All right. And the next presentation, I'll be handling over to Shubham.
Thank you, Vlad. So now I'll be talking about the data that we use for RelCAT. So we use two data sets. One is the public one, and one is collected in NHS in the UK. So beginning with the public one, we use the N2C2 dataset, and this has been created as part of the 2018 National NLP Clinical Challenge. And as you can see, it's open source, gold standard, and has been verified across multitude of studies. Across the 8 classes, here AD drug and duration drug are actually the minority classes. And later on, when we evaluate the model, it will be evaluated across general performance, F1 score, accuracy, everything. But also, we would be considering the performance on these minority classes as well. Nice. Uh, so you can't read that, but we have two different data sets from NHS. One is spatial, and the second one is physiotherapy. So for the spatial one, it's described as an entity pair where the left concept is located inside the right concept. So let me give an example here. So as you can see in this example, the pituitary adenoma is found inside the sella turcica. So that means these two have a relationship where the adenoma is located inside the sella turcica. So that is the spatial relationship. Now going back to physiotherapy, so this is defined as an entity pair where the left and right entities combine together to form a larger single concept. It is to note that originally the left and the right entity originally are concepts, but together they form an additional concept as well. So here the example would be of the wheeled Zimmer frame and the handheld assistance, where together they form an even larger concept. Additionally, as Vlad mentioned earlier, we use the SNOMED CUI codes wherever possible, but here for the A01, we don't have a SNOMED code, so we've defined a custom one. Now, so the overall workflow of RelCAT, MedCAT is that you have unstructured medical text, then you perform NER on top of it, and you get a lot of medical entities. And now you want to classify or extract the relationship between them. But majority of the medical entities would not be having any relationship between them. And that's fine, that's expected. So these entity pairs are actually non-relations. So the way we define non-relations is that um, you can have two types. A is where there is a relationship between those two entity pairs, but given the task at hand, we don't consider that. So that is kind of a non-relation, but not really. So we tend to refer these as other relations. And B is where there actually is no relationship between them, irrespective of the concept. So these are referred to as actual non-relations. So non-relations, so what is the challenge between them? Why is there a difficulty in handling them? So as explained, there will be a lot more of non-relations compared to actual relations in the text, and this needs to be handled because otherwise you will have class imbalance, which is tricky to handle. And additionally, these non-relations will contain other relations and actual no relations as well. And if not balanced properly, they will introduce bias as well in the model. So RelCAT has the ability to automatically handle this. So given the user's choice, A, it can only create non-relations with actual non-relations and not include the other relations. But in case you wanted to create these other relations as well, then you give the criteria, disorder, medication, symptoms, etc., and it would take that into consideration and then create these non-relations for you. So here you can see an example of fracture and liver function test, where majorly these won't actually be related to each other. So this actually will be our actual non-relation. So this is one example of that. So in RelCAT has the ability to generate non-relations by excluding these false negative relations. So false negative are actually the other relations that I mentioned. So now moving on to the training methods. So for RelCAT, we make use of three different models, BERT, Llama, and Mistral. But BERT and Llama are actually trained in the conventional sense where we train medical relation classification as a text classification task. And Llama 3 and Mistral are used for in-context learning, where we perform zero-shot and few-shot learning. This is a quick walkthrough of the data of how, given the input sentence, we tokenize it, and then upon tokenization, as Vlad mentioned, there are certain constraints, and after these constraints have been satisfied, we only take the tokens in the context window. We wouldn't want to pass 1,000 or 2,000 tokens when not required. So we only take X tokens left and right to the medical entities in question, and then pass it through to the models, both BERT and Llama. And in case of both, we take the hidden state output and also the pooled output, since we feel that pooled output actually contains good summary of the entire input, so that could be useful. But since Llama does not have that, we only take the hidden state output and then pass it through the final classifier. And now the in-context learning. So obviously in-context learning offers a lot of benefits. You don't need to actually train the models, and you can directly jump on to evaluating these models. So for that, we make use of Llama and Mistral instruct versions, and we provide explicit instructions on explaining what the task is and some description of the classes as well, so that the model has understanding of that. And along with using the vanilla zero-shot and few-shot learning, we are also exploring human-in-the-loop RAG fusion adaptation of optimizing these prompts. So basically, iteratively, we would improve the prompts given to the models, where let's say on iteration n, the model did not perform good for class A. Then we would perform error analysis, and we would see that it's struggling for class A. Okay, so in zero shot, we would describe the task better. We would describe the class A better. For few shot learning, we would do that, obviously, and also add a few more examples so that the model is able to understand and hopefully perform better in the next iteration. Now moving on to the results. So here is the performance for the N2C2 dataset. And as you can see for F1 and accuracy, it's quite similar. And the BORT model actually is outperforming all the other models. One thing to note here is that BORT and its variants, we have unfrozen all layers and we are training all of the BORT layers. But for Llama, since it's a huge model, only the last layer is unfrozen. So at first glance, the overall performance, it looks like the models are quite close. But when we dive deeper into the minority class, you see for ATE drug, Llama is especially struggling and BORT seems to be doing actually quite good. Now onto the NHA data sets. So here, instead of using the variance of BORT, we use the N2C2 trained BORT. So what is N2C2 trained BORT? That is a model that has been trained on the N2C2 data set with its layers unfrozen. So basically, it's been given a pre-training version 2. So it has more understanding of relation classification, and then it's been trained on this data set. So for spatial, Llama does good. Llama is outperforming other models, but it's not by a lot. It's a close shave. But for physiotherapy, you can see that the N2C2 BERT actually outperforms others, and Llama is quite behind. So this just goes to prove that there is no one silver bullet. Different models will work differently on different data sets. And here, N2C2 BERT actually offers a lot of value while being quite compact. That's all. Thank you. Any questions?
Thanks, Vlad and Shubham. We'll now take some questions. As a reminder, if you're in the room, please use the microphone to ask your questions. Okay, I'm not seeing any questions in the room. I'm not seeing any online. Maybe I'll ask a couple of questions. Have you explored integrating subsumption relationships within RelCAT to further enhance the depth and accuracy of relation detection between SNOMED CT entities in clinical narratives?
Yes, that's the post-coordinated SNOMED expressions in it, sort of. I guess that could be technically equivalent to the type of spatial relationships we've annotated, I guess, because those are treated as complex concepts. Yeah, that could be it. I guess a possible answer.
And what are the challenges of applying these technologies and methodologies to different languages?
Okay, so we've only tested this in English, so sorry.
Oh, no, that's okay. Any questions in the room? No? Not hearing any. With that, we'll conclude this block of sessions. Online delegates, you can rejoin the next group of sessions at 3:30 KST through the event lobby. Online delegates or on-site delegates, the afternoon break will now take place in the exhibition hall, where you can also view the e-posters and lightning talks. Remember to visit our exhibitors and play our passport game. Thanks, everyone.